In this video, we're going to look at another method for finding the volume of a solid of revolution. This is called the shell method. And this method uses what we call cylindrical shells to estimate the volume of a solid with circular cross sections. So you can see with this image, which I've pulled from this YouTube video here by Bob Martinez, basically what's happened is we've taken our solid of revolution and we've built layers around it, kind of like the rings of a tree trunk, if you will. And that's how we're going to estimate the volume of our shape is by looking at the volume of those circular shells or cylindrical shells. And we start with a representative rectangle, which you can see here. It is this one right here with a width and a height. So representative rectangle. And we spin that rectangle around an axis of revolution, and that's what forms each of the shells. So you can see a couple of different variables on here. We've got the width of our rectangle. We have, which is the the thickness of it. We have the height, which you might think of as the length of it. And then we have the distance between the axis of revolution and the center of the rectangle, and that's P. So P is basically the distance from this axis to the rectangle. And of course, when we revolve this shape, it forms a cylindrical shell, or you might think of it as a tube of thickness W. And there's a little bit of information here, like you can go to the center of the rectangle and get P minus W over 2. To the top of it would be P plus W over 2, because P actually goes to the center of the rectangle, no matter what that width is. To find the volume of this shell, we consider two cylinders, the outer cylinder and the inner cylinder. And the inner cylinder is technically a void, so we'll be subtracting it. The outer radius of the shell is that P plus W over 2, and the inner radius is P minus W over 2. So since this is a cylinder, and we know that its volume of a cylinder is pi times the height times the radius squared, what we end up with is pi times P plus W over 2 squared times the height, minus pi times P minus W over 2 squared times the height. And if you multiply and FOIL all this out and simplify, you get 2 pi PHW. And just like the disc and washer methods, we add all those cylinders together to estimate the volume of more complicated of solids of revolution. Now, ideally, we would have infinitely many cylinders, which would mean that the width of the cylinders would be getting smaller and smaller and smaller. So that W that's in this formula here, when we talk about infinitely many, that's going to be approximately dx or dy, depending on whichever direction you're going. So this involves an infinite sum, which we turn into a limit. And if you have a horizontal axis of revolution, that turns into 2 pi times the integral from e to d of p of y h of y dy. In this case, the w is representing dy. And if you have a vertical axis of revolution, we have 2 pi times the integral from a to b of p of x h of x dx. So the dx is in place of the w. And graphically, this is what it looks like. You got the same shape here. It's just we've solved it in terms of y here and in terms of x here, because here we have a vertical axis of revolution and here we have a horizontal axis of revolution. Just to flip you back to the disk method for a moment, remember that with a vertical axis of revolution on the disk method, you had your function in terms of y, and with a horizontal axis, you had it in terms of x. So that might give you a hint as to when you would want to use each method. It's usually easier to work with things in terms of x because that's what we're used to. This problem says use the shell method to find the volume of a solid of revolution formed by revolving the region bounded by y equals x minus x cubed and the x-axis about the y-axis, and that's the x-axis from 0 to 1. And this is about the y-axis is a vertical axis of revolution, so we know that we're going to be in this format. So we're going to be using the shell method here. And I need to fill in some information. So my h of x, which is going to be the height of the rectangle, is the x minus x cubed, which is the function. P of x is the distance from the axis to the rectangle, so that just gives me x. And then I'm going to have a equals 0 and b equals 1, because that's what we're given in the introduction to the problem. So v is 2 pi times the integral from a to b of p of x, h of x, dx. So this is 2 pi times the integral from 0 to 1 of x times x minus x cubed dx. So now I'm going to distribute that x, and I'll have x squared minus x to the fourth. And when I integrate this, I'll get x cubed over 3 minus x to the fifth over 5 from x equals 0 to x equals 1. So I'll have 1/3 minus 1/5 minus 0 minus 0. And that gives me 2 pi times 2 over 15 units, or 4 pi over 15, and this is going to be cubic units because we're looking at volume. So I get 4 pi over 15 cubic units. For this example, we're going to use the shell method to find the volume of the solid of revolution formed by revolving the region bounded by y equals the square root of x, x equals 4, and y equals 0 about the y-axis. So I have the shape here, and I've colored in my region, and we're revolving around the y-axis, so we're revolving around this line. And I need to label the pieces here, so I'm going to draw a rectangle. This is a vertical axis, so we're going to have vertical rectangles. And my h of x here will be the square root of x. So the distance from the axis, p of x, will just be x. It's the distance from 0 to x for whatever x is, and of course the height is the square root of x. And then a is going to be 0 and b is going to be 4 because those are the bounds of my region. So v will be 2 pi times the integral from 0 to 4 of x times the square root of x dx. Now remember, this is x times x to the 1/2. So this is going to be x to the 1 plus 1/2, or 3/2 power. And when I integrate that, I'll have x to the 3/2 plus 1, which is 5/2, divided by 5/2 from 0 to 4. 5/2 flips to be 2/5. And I'm really looking at 4 pi over 5 x to the 5/2 from x equals 0 to x equals 4. So this gives me 4 pi over 5 times 4 to the 5/2 minus 0 to the 5/2. And 4 to the 5/2 power is actually 32. And of course 0 is 0. So this gives me 128 over 5 times pi, and that's going to be units cubed. A variation on this problem is one where you're revolving around a different vertical axis. So this one says use the shell method to find the volume of the solid of revolution formed by revolving the region bounded by y equals the square root of x, x equals 4, and y equals 0 about the line x equals 6. So instead of revolving it around the y-axis and forming this kind of like cylinder with a cone taken out of it, we're going to be taking this shape and revolving it around the line x equals 6. So this is our axis of revolution. Okay, so h of x for a rectangle is going to be the height, which is just the square root of x. P of x, remember, is the distance from the axis to the rectangle. So if we want to know the distance and the shape of this line, or the width of this little segment here, whatever your x is, you're going to subtract it from 6. So this one, my p of x will be 6 minus x. And in general, whenever your vertical axis of revolution is on the left of the graph, so if your axis was x equals c, you would use x minus c, but if the axis is on the right of the graph, you would use c minus x, just to measure that difference. Our a is going to be 0, and our b is going to be 4, because those are the bounds of the shape. So v will be 2 pi times the integral from 0 to 4 of 6 minus x times the square root of x dx. So this is 2 pi times the integral from 0 to 4. If I were to change this to x to the 1/2 power and distribute, I would get 6x to the 1/2 power minus x to the 3/2 power. And if I integrate this, I'll have 6 times x to the 3/2 divided by 3/2, because I add 1 to the power and then divide by it, minus x to the 5/2 divided by 5/2, and that's all going to go from 0 to 4. So that will give me 6 times 2/3 x to the 3/2, and of course 3 will cancel, minus 2/5 x to the 5/2, all from 0 to 4. And I've got 4x to the 3/2 minus 2/5 x to the 5/2. So that gives me 4 times 4 to the 3/2 minus 2/5 times 4 to the 3/2 minus 0 minus 0. Which gives me 2 pi times, well, 4 to the 3/2 is 8 times 4, which gives me 32. And 4 to the 5/2, which is what we actually have here, gives me 32. So all of this together gives me 192 over 5 pi units cubed. And again, if you have a vertical axis and your axis x equals c is to the left of the graph, so your graph is somewhere over here, then your p of x is going to be x minus c. In most cases, that'll be x minus 0. If you've got a vertical axis of revolution, x equals c, and the graph happens to be to the left-hand side of it, then your p of x would be c minus x. It's always going to be the distance here. It's just a matter of how you calculate that distance.